Hi dear students, we are going to discuss about the next topic, and now we have discussed about the solid sphere like hollow sphere cases, a potential at various point inside a surface outside. Now we are going to use these concepts in a certain problems. So we are going to enter into the next topic, and there these applications are coming. So write on the heading potential in a concentric spherical shell. Potential in a concentric spherical shell. Okay. There are few things we are going to discuss, especially I can say three cases we are going to discuss. Okay, three cases means three different models. Okay, if you open any textbook, there is nothing called like a cases you cannot see, but I myself will be classifying this as different cases, and the three cases means three different situations, three different problems, three different numerical problems. That's what we are going to see. Okay, so let me see the first case. So write on the example case 1. What is basically called a concentric spherical shell? Concentric spherical shell means it's not only one shell, it is consist of more than one cells. I mean, first one shell, then on top of that or on around that another shell, so another shell, like that. So there are any number of shells we can place it, which is called which is all the spheres will have a common center. That is called concentric spherical shell. Okay, so case 1, the concentric spherical shell means shells are not connected and not earthed. This is one case. You cannot see the same heading in your Ncert textbook or any other reference textbook. This is based on a different aspect. I have filtered it out. Shells are not connected and not earthed. So we will take an example and we'll try to solve this one. Okay, so we have a spherical shell will be here. Let me take like two shells. The first shell will have a charges of Q. Second shell will have a charges of 2Q, and the inner shell will have a radius of what we can take it as R, and outer shell will have a radius of 3R. Suppose we are taking like this one. The inner shell is called A, outer shell is called B. So the diagram is very clear, right? So we have a spherical structure is available, and inner sphere is called R, its radius is R, its name is A, whose charge is equal to Q, and outside sphere whose radius is equal to 3R and charge equal to 2Q, and its name is B. What is our aim means we are going to find out potential at A and we are going to find out potential at B. These two things we are going to find out here. Okay, so potential at A and potential at B. So two steps we are going to find out. What is potential at A and what is potential at B? So normally in case of a sphere, okay, whose radius is R and outside rad point is R. So we have different points are available, right? Inside point, outside point, different points are available. So this is outside potential and this is surface potential, and if I am taking any point will be here, and this is inside potential. So we know the outside potential is equal to K into charge is Q, KQ divided by distance from the center to outside, which is called KQ by R. So potential at the surface is equal to KQ divided by the radius to the surface, capital R. And the last one, potential at inside will be equal to, what is potential at inside for a spherical shell is same as the surface value, which means KQ by R. So potential at surface is KQ by R, and potential at inside is KQ by R, and potential at outside is KQ divided by R. So we know all these three formulas. This formula we are going to apply, this concept we are going to apply will be here. We'll say, so we have two spheres, different radius and different charges. So we don't want to bother about what it is, but we are finally going to find out the answer for the question. So we are going to find out potential at A. Potential at A means we are going to find out potential at A. So potentials are given by any charges. So A will have one charges. What is that charge? Q. And the potential, if I am going to find out at the surface of A, means I am finding with respect to A, I am finding on the surface. So surface formula is what? KQ by its radius. So KQ divided by its radius plus. The potential at A is also given by another charge. What is another charge? 2Q. So this sphere will give, the outer sphere will give a potential at A. So with respect to B, it is an inside point. With respect to B, it's an inside point. So what is the potential at A due to B? Potential at A due to B means because of B, it's an inside point. So what is the charge? K into 2Q divided by inside. Inside means what is the potential? Same as its radius. So 3R. This is a concept here. We can simplify this stuff. So KQ divided by R we have taken outside, and 1 plus 2 by 3, which is equal to KQ divided by R into 3, and it is 5 by 3. So KQ by R into 5 by 3. This is the potential at A. Okay, so I am going to find out the potential at B. This is a concepts we have learned the middle part, and this is the answer for the questions. Now we'll go to potential at B. Potential at B means I am going to find out the potential here. So potential here means potential due to A will be there and potential due to B will be there. What is the potential due to A? With respect to potential due to A at the point B means for A it is an outside point. So what is the potential at outside? KQ by small r. So KQ by small r means distance from here to here. What is the distance? 3r, correct? From here to here the distance. Small r means center to outside distance. From center to outside distance is what? It is 3r. And plus. Next, potential due to B. What is the potential due to B? Potential due to B means it's on the surface. So what is the surface formula? K into 2Q divided by 3R. We have to add these stuffs. So what we'll get? KQ divided by 3R is common, and 1 plus 2. Correct? 1 plus 2, and totally we'll got 3Q by R, and 3 and get cancels, and KQ divided by R is the right answer for the potential at B. So this is case number 1. The heading says that shells are not connected, which means there are two shells will be there. Shell number A will be there and shell number B will be there. Shell A is not connected with the shell number B. There is no connection. One case. And there is no earthing. Earthing means there is no grounding. Nothing will be there. It just simply two shell. This is one model of questions which are commonly coming for a Neet and JEE examination. I have seen these questions lot of times for in your entrance examination. This kind of case number 1 model. Hope you understood. The potential at A will find it because of the two sphere, and potential at B we are finding because of the two sphere. Okay, this is the first case. Now we will move to do the second case. Okay. Fine. So first case, understand, first case there is no in short there is no physical connections and there is no earthing. Okay. In case number 2 it's slightly different. In case number 2 what we are going to do, shells are not connected but earthed. Shells are not connected but earthed. We will take one examples will be here. So the same example I will take it will be here. This is shell number A, this is shell number B. Charge is Q and charge is 2Q, and this shell is earthed. Any one. This is like 2 shells I have drawn. In examination there may be 3 shells might be asked. So concept is same. Radius is R and the radius is 3R. Okay. So in these cases, what you want to do means, suppose they are asking you a different value. Suppose I need to find out what is the charge on Q. Okay, maybe I will say like I'm taking this charge as Q dash. Then I'm framing the questions like this one. What is the charge on sphere A? What is the charge on sphere A? What is the charges available on the sphere A or on a sphere B? Anything it will be fine. So our concept is like, if you have seen some earthing Earthing means grounding. Ground means what is the value of potential. Earthing means potential is equal to 0. So if you see some points like this one, immediately your first answer will be potential is equal to 0. You have to write. Then you are going to find out potential will be here. So potential here means potential due to A itself and potential due to B. So what is potential due to A? K into Q dash divided by its radius is R plus. Potential due to B on this point. So with respect to B, it's an inside point. So K 2Q divided by its radius. Its radius means what? 3R is equal to 0. So what will happen? K by R and K by R will go to 0 and we'll got Q dash plus 2Q by 3 is equal to 0 and the value Q dash is equal to 2Q divided by 3 minus 2Q divided by 3 is the value of 2 dash. If the value of Q dash. The same model of questions in entrance examinations might be comes with 3-layer structure. They will give you this is called A, this is called B, this is called C. Its radius is R, its radius is 2R and its radius is 3R. Charges are maybe this sphere is entered and we need to find out the value of Q dash. Here it is Q and here it is 3Q. Then what is the value of Q dash? They may ask like this one. They may ask such kind of questions to you. Okay, so in that case the same logic you have to apply. So the sphere A, B and C will be here. So we have two spheres will be here. This is sphere A and this sphere is B and the last sphere is C. So how we will answer such kind of question? This is a simple question. This is a little bit an advanced model of question. How we will answer such questions? We will say, so what we'll do, we need to find out Q dash for this question, right? So I can say potential at B is equal to 0 because B is grounded. So I'm going to find out potential at this point. So potential at this point means potential due to A, potential due to B and potential due to C. So 3 points will be there. So potential due to A I am going to calculate. So VB is equal to 0 which is equal to potential due to A plus potential due to B plus potential due to C. Okay, so what is the potential due to A? A means K Q divided by, with respect to A, this is an outside point, so 2R. And potential due to B, it's a surface point, KQ dash divided by 2R. And with respect to 3Q, it is an inside point, so K into 3Q divided by inside radius is how much? 3R. So for A, it is an outside point. For the A, it's an outside point. For B, it's a surface point. For C, it's an inside point. So 3 different concept will be there. So what all things will be cancelled? K by R, K by R, K by R will get cancelled. All will be equal to 0, right? K by R will get cancelled. All equal to 0. So what is balance will be there? Q by 2 will be here. And here we have Q dash by 2 will be here. Then what else will be there? K by R cancels. So 3Q by 3R. So 3 and 3 also will get cancelled. So we have Q will be equal to 0. So Q plus Q by 2. I can say 3Q by 2 is equal to Q dash divided by 2 minus. So 2 and 2 will get cancelled. I can say Q dash is equal to minus of 3Q. Q dash is equal to minus of 3Q. I got the value. So this is the model of questions which are normally coming. If you see earthing, this is the key point will be here. This is a key point. Potential at B is equal to 0. You have to equate and you have to find potential due to A with respect for A it is an outside point, for B it's a surface point, for C it's an inside point. So 3 different formulas and concepts you are applying in a single question. Okay, in a single questions you are applying. Okay, next we are going to see the third case. So hope you understood this concepts. Okay, so in the third cases I would like to give one informations to you. In third cases, case number 3, you get 3 different combinations. Shells are connected and not earthed. Any combinations you can make. Shells are connected and not earthed. Let me take the same example and we'll see. So A will be there and B will be here. Suppose I'm assuming A will have radius 2R and this will have radius 2R. This will have a charge 2q and this will have a charge 7q. Okay. Now with respect to a switch, this can be connected. Now if this is connected, then the question is, what is the charge, what is the charge transfer? Definitely this will have a lower charge, this will have a higher charge, but this will have a lower radius. Lower radius means higher potential will come. This will have a higher radius, which means lower potential will come. When two balls will have different potential, if they're connected together, both will attain same potential. So same potentials will be here. So what I'm assuming like that, now I'm assuming the charge, some amount of charge flow will be happening in any one of the direction. I don't know, I'm assuming from inner to outside a q coulomb of charge is assuming, a q coulomb of charge is transferring. What is the value of q? Okay, how much is a charge transfer from smaller charge to bigger charge? So let me frame the question. What is the charge transfer? What is the charge transfer? What is the charge transfer from inner sphere to outer sphere? Here the main concept is like, if two in case of, we have say like, if it is earthed means potential is equal to 0, but here it is not earthed, it is connected. It is connected means potential at A will be equal to potential at B. That is a concept. Potentials are same. That is the meaning of connection. Connection means potentials are same. Earthed means potential is equal to 0. So potential at A, here I am to find out. So potential at here means potential due to A and due to B, two things. So with respect to A, potential will be equal to K into, I am assuming 2q minus of q, minus q, the q amount of charge is transferred, so minus q. Okay, I don't know what is the value of q, but I am just assuming it is just transferring. It may be in this direction or it may be in this direction. I am not bothering about the direction. If I am getting positive, it is saying like that charges are transferred from this inner to outer. If I am getting negative, I will say charges are transferred from outer to inner. So you don't want to worry about the sign. So assuming divided by, so charge divided by its surface radius is r. And what is the potential at A? Because of B means K into 7q plus q. 7q will accept the charges, 2q will release the charges, divided by, for B it's an inner radius. What is the inner radius? 2r is equal to potential at B. We are going, potential at B means with respect to B its surface, and with respect to A it's an outside point. So outside and surface formula we have to apply. So first we will apply the outside point. Outside means K into, what is the charge will be here? 2q minus of q divided by, for outside its radius is 2r plus, and for B it is what point? It is a surface point. So K into 7q plus q whole divided by, it's a surface point. Surface point means its radius is 2r. We have to equate this and we have to find the answer for small q. That's what we are going to do. Okay, so what are the things will be get cancelled? K by r cancel, K by r cancel, K by r cancel, K by r is also cancels. So we'll simplify will be here. So 2q minus q plus, okay, 7q plus small q divided by 2 is equal to 2q minus q divided by 2 and plus 7q plus q divided by 2. Okay, so in order to make it a very little simple way, left hand side multiplying with the 2, right hand side also I am multiplying by 2. So I am removing this area. Hope you have written till here. So we'll move forward. Okay, so this area I am clearing. You can pause the video so that you can complete your notebook also. Okay, so this is not required, only these steps we have. Throughout I am multiplying with the 2 to make my calculation easier. So 4q minus 2q is equal, not is equal to, plus, second step, 7q plus q is equal to 2h, it's also multiplying on the right side. So 2q minus q plus 7q plus q. What will happen? This minus q and this q will get cancels. 4q and 7q, here how much will come? 11q minus 2q plus q, minus q is equal to 7 plus 2, 9q. Okay, so this is taken to left side. So 2q is equal to 2q. So this is answer for this one. So q is equal to 2q. I got a positive value which indicates charges are transferred from lower to the bigger sphere. Lower sphere will have the higher potential, not highest charge, highest potential. Charges are always flowing from, not from higher charge to lower charge. That is not correct. Charges are always flowing, or the currents are always flowing from higher potential to lower potential. So our assumption, we have taken from smaller sphere to bigger sphere, charges are following. That is assumptions we have taken, right? We have connected the wire. So I got a positive value, which means a q amount of charge is transferred from 2q to the other one also, the other sphere also. Okay, so q amount of charges are transferred. So three different concepts we have learned, three different things on charges are it is not getting connected each other. It is not connected each other means we have to find out the potential at each and every point of the sphere. If it is a 2-layered sphere or maybe 3-layered sphere, no problem. In some cases like the second case, for example, we have a earthing case will be there. Whenever you see in a diagram something called earthing, immediately you write a potential is equal to 0 and you formulate the equation and you find out whatever is asked in the questions. This is the second point we have learned, and in the third concept we have learned like connection of wires. What will happen if connection of wires will be there? Connection of wires means potential at one sphere is equal to potential of the next connected spheres. Okay, that is a concept behind will be here. Okay, so I have to tell you one more tricky informations to you. Normally they will ask you some questions like this one. Okay, they'll ask you some questions like this one. They will give you a different radius, a different scenario. For example, this is one special case, so we will write a special case so that it should be there. This must be there on your notebook. So special cases, here we have a charge q and here we have a charge 2q, and this is sphere A, this is sphere B, and this is sphere C. Okay, then the question is asking what is the charge on sphere C? What is the charge on sphere C? Here you have to apply one concept, one important concept you have to see. Okay, if q amount of charge will be there on the inner sphere, then we have learned charging by induction property. So what charges will be induces on this sphere? Q in the opposite means minus q will induce will be here. So what is the total charge will be here? 2q plus minus q. 2q plus minus q is the charge. So I can say charge on B is equal to 2q plus minus q is equal to what? Is equal to q. Now I know q amount of charges will be induced on the number sphere B. Okay, now this minus q is coming, this minus q is coming because of the plus q. Okay, so this minus q is induced because of the sphere A, and sphere A will induce a minus q charges will be here, and minus q plus 2q plus q will be the charge on the sphere B. Okay, so if you are taking the same concepts will be here, then what will be the charges are induced on C? Okay, induced on C means the opposite charges will introduce. So this q raised to minus q will introduce, and minus q plus 2q, and 2q will be the net charge will be formed. So at the same time, here it is plus 2q means this q will induce a minus 2q will be here. This plus 2q will induce what charge will be here? Minus 2q will induce. So this will induce a minus 2q charge on the sphere. Okay, so this q will induce a minus 2q. So let me make the diagrams in a better clear format so that it will be little more easier to you. Okay, so this is a sphere A, this is a sphere B, and this is a sphere C. So here if it is q will be there, then what will come will be here? Minus q will induce. Already what is available will be here? Plus 2q. Because of the plus 2q, what will induce will be here? Minus 2q. This is a concept. Now, What is this all over the concept is indicating? So immediately if you see q will be here, definitely if it is a shell, you can say here minus q will be here. If it is plus 2q will be here, you can say minus 2q will introduce. So what is the concept behind this one? So if you see this area, if you see the shaded area, okay, what is the electric flux will be here? Flux will be equal to charge enclosed by that area divided by epsilon 0, Gauss's law in electrostatics. So what is the electric flux? Electric flux will be equal to 0 because 2q minus q, this 2q is already there and minus 2q is the induced one. So because of this one, total charge is equal to 0. Total charge will be equal to minus closed integral E dot ds will be equal to 0. Surface area will never 0. So what will 0 will be here? Electric field will be 0. This is important. This is important. Now I'm coming to the answer to the question. What is the charge? Our question is charge on C. Charge on C is equal to what? Charge on C is equal to minus 2q. Now in addition I'm writing charge on B is equal to what? Charge on B is equal to minus q will come here. Already 2q will be here. So as I told before, 2q plus minus q, I'll get an answer is equal to q. Okay, this always you have to remember in between the spaces, So if you have considered this Gaussian surface, so this is the outer one, Gaussian surface number 1. What is the total electric flux within? Minus q plus q 0 plus 2q minus 2q 0. Electric flux will be equal to 0. If you are considering this Gaussian surface G2 means within this one, charges are enclosed, minus q plus q, it is equal to 0. So whenever if you see some shell gap, whenever this is a shell, this is not a gap, this is just a circle, but this is a shell gap, this is a shell gap. Whenever you see a cell gap, flux equal to 0, electric field is equal to 0. Important concept. This one is very, very important to understand this stuffs. So always remember in mind, shell, one charge will be induced on the other one, and in the gap flux will be equal to 0 because both are opposite signs to each other. Hope you understood what we have discussed in this topic. Concentric spherical shell electrical potential concept is very simple. 4 major points we have discussed. First one is no earthed, no connection. Second one is earthed but not connected. Third one is earthed means potential is equal to 0 at that particular sphere. And the last one is like and the third one is like connections will be there, which means potentials are equal. This is one point. And the final point what we have discussed about is like induction property is also there in a connected solid spherical shell. So within the every gap between two shell gap, potential, the electric field is equal to 0, flux will be equal to 0 because of the charging by induction, not conduction. Conduction means connection is there. There is no connection here. This is induction property. So hope you understood these topics very clearly. Okay. So thank you, and thank you for listening it. Bye. We'll move to one concept what have shown to you in a different way, not in a different way, but that is a concept. Okay, so using the induction property, we're going to solve one example for a concentric spherical shell. Okay, so listen very carefully. This is the questions we are going to solve it here. Okay, my question is, there are charges are different. Okay, so the question is, I want to find the charge on the body C. This is body number B, this is body number A. Okay, so we are writing the question for the given spherical shell, for the given spherical shell. Okay, what is the charge? What is the charge on C? We are going to find out what is the charge on C. So charge on A is given Q, and this is given 3Q, and we have to find out charge on C. So we are applying the induction property, and because of Q, what charge will induce here? Minus Q. So what is the total charge will be here? 3Q plus minus Q. So the total charge at this point is 3Q plus minus Q, which is equal to how much? Plus 2Q. If it is plus 2Q, is a total charge will be here. What is the charge will induce here? Minus 2Q. So the answer to the question is charge on C equal to minus 2Q. So what I'm trying to say you here is like, if there is no 3q is not there, if there is no 3q is not there, then what will happen? Q will be here, minus q will be here, plus q will be here. But because of plus 3q, the induced charge is minus q, and this minus q will add that up with the plus 3q. Then we'll get a total charge 2q. Now the total charge on B is 2q, and this 2q will induce its opposite charge minus 2q. So charge on C is equal to minus q. Suppose if the question is like this, here it is q amount of charge and B, and this is C and this is A. Question is asking what is the charge on B and what is the charge on C. B and C charges. We'll write B and C charges is what, if the question is like this. Then here it is q, then what is come? Minus q. If it is minus q, what will come will be here? Plus q. Okay. So as I told before, the interspace distance q plus minus q 0, minus q plus q, it is always 0, which means flux will equal to 0 and electric field will be equal to 0. This is what we discussed. In this case, the charge on B is equal to minus q and charge on C will be equal to plus q. If already some charges are there, you have to add with that charges. But if there are no charges will be there, means you don't want to add it up, you can just take it one step upward from the inner positions and you are going inside. This is what you are going to do. Okay, hope this concept is clear to you, whatever we told. Okay, we'll move to the next topic. Okay, so we'll write the next topic heading, which is called most important one, which is called equipotential surface. Equipotential surface, very important. Okay, very much your attentions are needed to this one, then the concepts will be very clear. Equipotential, what is called equality? Equality means same, right? Everywhere it is same. That's the meaning of equality. So equality means it is same, potential means voltage, so equipotential means same voltage. So all over it is same voltage, that is called equipotential surface. So the definitions will be equal to the surface, the definitions will be equal to equipotential surface means surfaces which has same potential, same potential, that is called equipotential surfaces. We will take one examples will be here. Suppose I have a sphere like this and whose radius will be equal to r. The charge on the sphere, okay, not the charge on the sphere, I have placed one charge will be here q. I have taken 2 points, A point and B will be here, this is A, and C will be here. What is the potential at A due to q? 1 by 4 pi epsilon 0, that you know it is called k, a constant, k into q divided by r. What is the potential at B? You can say kq divided by r. What is the potential at C? You know it is also kq divided by r. So if you look into the spherical structure, a charge will be there at the center and all the positions, if you are looking, the charges are same. Not the charges are same, I mean the potentials, the voltages are same. Potential at A is equal to potential at B. This point is B. Potential at B is equal to potential at C. So I can say potential at A is equal to potential at B is equal to potential at C, and if such cases are existed, then this is called equipotential surface. So equipotential surfaces are the surface in which the potentials are all over it is same. But instead of taking like this one, suppose I am taking an irregular structure and if I placed a charge will be here. So potential here, potential here, potential here will be same or different? It is different because charge will be there but the distance is r1, this distance is r2, this distance is r3. So the distances are different, A, B, C. So you can say potential of A is not equal to potential of B is not equal to potential of C. I cannot say like this. I can say like this, which means potential at a different points are not equal because of the difference in the distance. Okay, but here distances are all over same, so this point is called an equipotential surface. That's what I'm saying, surface which has the same potential. So this is a surface and wherever you take same points, that will have some potential value. So potential we are calculating kq divided by r. So that is the definition of equipotential surface. Next important point we are going to write down. Now hope you understood the concept what is called a potential. Potential of this point equal to potential of this point. Then I am saying like this point, this surface is an equipotential surface, I can say, or I can say this potential is equal to this point potential. If a charge is placed, it will be here. So potential here and potential here are same. I will say this point and this point are equipotential points, which means both will have same value of potential. Okay, we'll move to the next important stuffs for this one. Okay, that is called properties of equipotential surface. This equipotential surface will have lot of speciality or lot of features are there. So we are going to see that one. So write on the heading properties of equipotential surface. Properties of equipotential surface. This is important your school board examination point of view also, not only for your entrance examination, school examinations also, your theoretical board examination point of view also, this is important. First one, equipotential surface and the first property, potential at every point is same, So this is what we have seen an example. A Q is placed will be here at a distance of R. So potential at A and the point B. So I can say potential at A and the point C. Potential at A is equal to potential at B is equal to potential at C, which is equal to KQ divided by R. This is what we already see. Second one, potential difference is equal to 0. Potential difference is equal to 0, which means how we normally representing the term called a potential difference. We will write delta V. So potential difference means any 2 points if you are taking VA minus VB, it is 0 because both are equal potential. VA minus VC if you are taking, it is 0. And if you are taking VB minus VC, any 2 points if you are taking, if they are both are in the same potential, then the potential difference is equal to 0, and that is called equipotential surface. So equipotential surface means potential difference is equal to 0. Potential at every point is same. Potential at every point is same. That's what all values are same means if you are taking the difference of all these values, then the potential difference is given raised to 0. Okay, hope you understood these 2 points, and we have still further points will be also there. So I'm clearing the board. So first 2 points you can note down. Okay, we'll move to the next point. Next point means third point. So third point, work done. Who will do work done? By an external agent. Work done in an equipotential surface. Work done in an equipotential surface is equal to 0. Work done in an equipotential surface is equal to 0. So let me take an example. Suppose, okay, the same examples. This is circle, a charge will be here. So I know the potential at the point A will be here. I know the potential at the point, okay, this will be considers point number B and this is considers point number A. So I am asking you, what is the amount of work I have to do to move a Q naught coulomb of charge from B to A. So I am doing the work from B to A. So B to A I am doing the work is equal to the moving charge into potential B to A means final potential minus initial potential. This is what we have learned, right? Okay. So B to A I am moving. So A is the final point, B is the initial point. So work done equal to Q naught into VA minus VB. So the potential at A is equal to potential at B. If VA and VBs are equal, the work done is equal to 0. That is the statement is saying. Work done in an equipotential surface is equal to 0. If you are doing a work in an equipotential surface is equal to 0. If you are moving a charge from Q0 to A, Q0 charge I am moving from B to A. Q0 charge I am moving from B to A. You are asking me how much energy I have spent. I will say 0 energy I have spent. Why? because I am doing a work in an equipotential surface. If there is no potential differences, which means you are not doing any work. That is the meaning of work done in an equipotential surface is equal to 0. This is a very, very important point. Most of the year, either for your Neet or for your JEE entrance examination, there are numerical or some questions are there based on this concept. So this is very important. Keep it in mind while we are doing the question also. This point will be pop up in different places. So keep it in mind. Potential, we'll find one point, another point. Both the potentials are equal. Potential difference is 0, which means equipotential surfaces. That means work will be equal to 0. Keep it in mind. We'll move to the fourth point. Electric field is perpendicular to the surface. Electric field is perpendicular to the what surface? Equipotential surface. Equipotential surface. Here we need some explanations. Okay. What saying? Electric field is perpendicular to the equipotential surface. I know this is an equipotential surface. What is electric field? Perpendicular. What is electric field? Perpendicular, which means this electric field will make 90 degree. That is a property will be here. Okay, so we know it's a positive charges. So the positive charges will be giving rise to a positive charges is giving rise to an electric field. So this electric field from a positive charges are going away. If it is negative charges are, it's coming inside. But in both cases, electric field is vector is perpendicular to the equipotential surface. This is the surface and it is perpendicular. We can prove it mathematically also. For example, already we have learned an equations called dV is equal to minus of integral. Okay, integral we leave it. We already learned delta V is equal to, if there is no changes, then E dot dr we have learned minus. This formula hope you remember. Okay, the potential difference is equal to E dot dr, or we'll also say dV is equal to minus of integral E dot dr. I already told to you couple of times where we will use integration, where we will not use integration. For a discrete system, we will not use integration. For a continuous change with respect to distance, with respect to time, we will use integration. But both equations are same. One integration will use in context of continuous changes. If there is no continuous changes, we will not use integrations. So this is a general formula. So E dot dr. So what is called here? Potential differences. In an equipotential surface, what is a potential difference? This is actually called our delta V, right? Delta V is 0 will be here. So which means equal to 0, which is equal to E dot dr. Dot product means what? 0. How we will get electric field and dr? Electric field is not 0 because charges is already present there. Charge will be there means electric field will be. Then how it is 0? Here it should come with 90. Cos theta is coming. Dot product we are expanding. So E dr cos 90. So to become this is 0, definitely what should be the condition? Theta will be equal to 90 degree. If theta is 90 comes only, this factor will goes to 0. Theta 90 means what? The angle, I can say, angle between E and dr. Dr means the surface. For the surface, the angle between E and dr equal to 90 degree. So this is a surface will be here. This is a surface. So this is our dr. So this is our electric field. This is our dr, the surface. The tangential line is called surface. So electric field is always perpendicular to the equipotential surface, which means equipotential surface means the vector form of equipotential surfaces is dr, and electric field. Electric field means E. What is the angle between E and dr? Which is called 90 degree. That's what it is saying. Electric field is always perpendicular to the equipotential surface. For example, you can see in my hand you have a duster, and this point everywhere potential is same. Then the electric field vector is like this, perpendicular, like this, perpendicular 90 degree. Remember this point. This is also important. So 4 points are over. We have one more point, the last final point, 5th point. Okay, fine, perfect. 5th point. So 5th point is saying like two equipotential surfaces. These all the properties are important while we are doing the numerical questions. Okay, two equipotential surfaces will never cross. Two equipotential surfaces will be never cross. For example, you can assume this is an equipotential surface. Okay, you can assume this is an equipotential surfaces. Okay, I have another equipotential surface like this one, for example. So these are the two equipotential surfaces. If I am assuming this is equipotential surface number 1, this is equipotential surface number 2. So this kind of arrangement, one surface is like, maybe I can remove this part, will be here, and we will make it clear. So it's coming here and it's going out. Okay, so two surfaces are crossing here. This is not possible. Why? Because I told you that electric field vector is perpendicular to the equipotential surface. So this duster is one equipotential, this S1 is this duster. So what is electric field vector? Going upside, which means electric field vector is going upside. Okay, so S2 is a surface like this. So what is the direction of electric field? Direction of electric fields are like this. So this is one electric field and this is another electric field. So which means that at this point, at the joining, at the intersection, there are two constraints will be here. Electric field lines will never cross each other. So that rule is violating here. So that is not acceptable. One point. And another point, at this point, if you are asking me what is the direction of electric field, I am saying towards right. Another guy is coming and saying it is towards upside. It is not possible. One point, electric field vector will have only one value, not two directions. So two direction is not possible at a point. Only one direction is possible. So why two equipotential surfaces will never cross each other means two reasons. If it cross, there are two constraints will be there. What are the things will be there? Electric field lines cross each other. That is not possible. It's not possible. This is one reason, and another reason, at a point electric field have two directions. Electric field will have two directions. That is also not possible. Electric field should not have two directions at a point because it's a vector quantity. Vector quantity means it has only one direction at a certain point, not two direction. Here two direction, right and going upside. Single point, not possible. Single point, two lines will never cross each other. Because of these two reasons only, we are saying equipotential surfaces will never cross, will never cut, will never cut each other. So equipotential surface has a no crossing each other. So we learned the concept of equipotential surfaces, and we have learned 5 properties of equipotential surfaces. So all the 5 properties we will use it while we are doing the questions. Okay, hope you understood the concept of equipotential surfaces and the properties of equipotential surfaces. Okay, all the best.